When I first pioneered the high frequency 20,000 hertz electronic treadmill, I simply put aluminum foil plates on the outputs, put short bulbs on the outputs, and figured that the capacitive plates in space would serve as a capacity between the two short bulbs on the high frequency transformer. You may see that. This is a solid state transformer, and it's rated at 20 milliamps, 20,000 volts maybe. I'll have to go look on there and verify that real quick. Energy saving electronic gas tube sine power supply integral plus. I do not see the ratings on there. I'm not going to waste time on that. I know it produces 20 mA on short, probably at 15,000 volts. Yes, that's what that is. And then, well, like I said, when I made the electronic treadmill plate device, I wondered why it didn't work well at all with just those two xenon bulbs I selected for the plates, and I had to add two long 12-inch bulbs as a sort of ballast to get the whole thing to perform as it will perform, shown here, with only two bulbs. This is for electro-horticulture at high frequency, and going back here, we'll turn it on, but first we're going to go through here, and if I can, close enough to see the notes myself, hopefully. What we're doing here is trying to figure out the capacity that we need to place on the transformer. And using the capacitive equation K, dielectric constant, which is 1 in air, epsilon naught, which is the permeability of free space, times A divided by D. So we arrive at a figure of some 750,000 ohms. Let me check the camera. It's always a pain in the ass and I have to do everything myself around here. Nobody will help me. I'm looking still. That should be sufficient. So we're going to know the capacitive reactance necessary for that. And we arrive down here at a little over 10 picofarad. So that should be necessary to see that. I'm not going to go into that anymore. I'm just going to demonstrate the damn thing. Okay then. We used I thought at the time, many years ago, that simply having A and D for a formula would suffice to find the capacity, which you find out that the 10 picofarad is an extremely small capacity. However, this may be used to our advantage because it's the approximate dimension that you can put a damn plant into. And here then, we got a stubborn tray of pepper seedlings coming up, and we'll turn that on and end this video. Show the components a little bit maybe. Okay, let's look in the camera again. Camera work is burdensome. We have no assistance. You might notice that right hand bulb is not lit. That one right there. It has the habit of ionizing soon after the process started. See, that's how good investigative work works. Okay, so what we got then is we got 3 neons in front of what we determined by formula A divided by D and etc. on down the line. Not the metric formula with meters. We use the CGS system, and that's approximately 30 square centimeters plate area divided by 43 height, which is a high cube, a heightened lengthened cube, and that produces the effects that we need and can show. And as we should probably know, you can't simply stick a bulb with your hand in there to show the high frequency effects, because your body will make the bulb light. So here's the bulb, a longer neon bulb suspended over the plant tray. There's the 40 torr bulb connected to the ground plate. Sometime it might take some while to focus on that. It's a rather spectacular kind of Halloween Frankenstein discharge with that fill. And the other one's pretty much, that is the white clip is connected to the transformer. The red clip is connected to the bottom plate. Likewise on the other side, we can't see it, it's shifted. Let me get over there and put it back like it should be if we can still see it. I'm wasting a lot of time here. Oh, there's my bulb. This is what I wanted to show here. The handheld effect. If that's the plant, that's the electricity going through the water in the plant in a vertical fashion. Unfortunately, I don't have a cameraman. Gonna have to look at that again. Of course, we missed the whole thing. There's too many things to show here. It really is. Okay, we're gonna hold that bulb vertically again. Horizontally, practically nothing. Vertically, good high frequency ionization there, see? If the camera can capture that. Shocked doing this before. I'm going to straighten that bulb out. And we'll close out by showing that. Can't see it by the camera very well. These videos always get too long. Try to make them short and to no avail. And there's the handheld bulb. Surprised I didn't get shocked. Next to the string held bulb. Next to the top plate xenon. Thank you. Well, I've got to play around with this always, right? There you are. Well, pretty.